to all. In this morning, I find myself with Dr. Molina. I heard a few questions about black holes. Well, I want to know who did Albert Einstein discover black holes?
Okay, morning. Thank you. I'm afraid I didn't understand. How? Okay. How did Albert Einstein discovered? Okay. Black holes are consequence of precise mathematical equations. So I imagine that he was working in his equation, and at some point when you solve these equations, you find what's called singularity in Einstein equation or the universe equation, because he was trying to understand what's the shape of the space-time. Before him, we used to live in a Newtonian space,
Okay.
or a Newtonian universe. So after that, Einstein was trying to imagine how was the space and time, or how was time correlated to space. So he started to work with this differential geometry, and when you solve this equation, you find this singularity. It's like when you try to make a division by zero. You know, when you divide by zero, you obtain this kind of singularity. So this is interpreted as black hole.
Okay. I want to know what is believed to be in the center of the black hole.
Okay, that's a very interesting question, because I don't know, nobody knows. But as you said, what's believed, we believe that in fact Stephen Hawking showed that our universe comes from a singularity, like a black hole.
Okay.
So in the middle or at the center of or inside this black hole, there must be this this space. I don't know if calling it space is right, because inside the black hole we have no space and no time, because physics laws do not work inside. But what we know is that our universe came from a singularity, like what is inside the black hole, but we don't know what is inside. It's like the Big Bang. Big Bang is itself another black hole. So our Big Bang is we know that this Big Bang came from the singularity.
Well, how big must a star be to able to converge in a black hole?
Okay, you wanna know the radius of the star. Okay. There's no a fixed quantity, in order to a star collapse into a black hole, but everybody that is must fulfill this requirement of having the Schwarzschild radius. It's a quantity in which, let's see, for instance, the sun. The sun has some radius. It's like a sphere, and it has a mass and it has a density, because density equals the is mass over volume, right?
Okay.
So if you maintain this mass and let's decrease this this volume, you know that the rate of density will increase. If you make this this body, this has a density, volume, mass over volume is density.
Okay.
So you have mass inside is a constant value, and you make decrease this quantity. Let's change this quantity for this. So the rate mass over this denominator make increase the value of density. Okay? Okay, so if you continue decreasing this quantity, so now you have this, and you have the same mass over this tiny volume, so you have a bigger density, and so at some point the density will be so big that space cannot contain this quantity inside, so because the density is so big, so this collapses into a black hole. When this happens, you call this the social radii.
Okay.
It's not a fixed quantity. It's a quantity that depends of the mass of the object. When you have when we are talking about objects, we are talking about stellar objects. They are very big objects.
Okay. What happened with the time in the vicinity of a black hole?
Okay. What happens is this is just it's driven by relativity.
Okay.
When you have a very massive object, this is so massive that even light cannot escape from black holes. I don't know if you saw this image from the black hole recently. It's because you are not really seeing the black hole, but you are seeing the absence of light in this black hole. So the same happens to time, but time is related to space. As I told you with the Einstein equation, you can really see how.
What is singularity of a black hole?
Okay, as I said to you your first question about what is a black hole and singularity are the same thing. It's just a different interpretation of the same phenomenon, because when you solve the Einstein's equation, by the way, it's pretty hard to solve this equation.
Okay.
First time I solved it, I spent about a month, more than almost 2 months, to solve the first time. It's very hard, but once you are used to solve this, you are able to see what's going on. Okay, just imagine you are working in an equation like limit, in calculus, when you limit when x tends to 0 of sin of x over x, maybe like, yeah, it's like you're dividing by 0, and we don't have a physical meaning for this mathematical expression. So making this analogy, or translating this analogy to the Einstein's equation, we have a non-real term in these equations. So this is called, or we know this as a singularity, and after some time physicists interpreted this as black hole. At first, the first time, it's just a mathematical term you have in your equations. After some time, this was interpreted or called black hole. Black hole wasn't physical property. It's just that in mathematics this was like a, we don't know what this is. And after some observations from cosmologists and something we came to know this observation, this stars collapsing into itself as black holes. So in the same way that the space changed its shape, you expect that time also changed. So when you are near a black hole, nothing can escape from this body. So as the space goes inside the black hole, so the time, in order to maintain this quantity called space-time, the time goes slower. So if you are near this black hole, you will be forever in this called space of the black hole or the
Okay.
same thing.
What kind of energy do black holes emit?
It's just energy in the form of radiation.
Okay.
It's called Hawking radiation.
Hawking radiation. This is a name.
Yeah,
Hawking
it's the
radiation.
name. Hawking, he proved that black holes indeed emit this energy in the form of radiation. This radiation comes from the zero. He proved that black holes indeed emit this energy in the form of radiation. This radiation comes from the 0 point emission of the universe. These
Okay.
particles, nobody knows where does they come.
Okay. What is the difference between a black hole and a wormhole?
These are just different interpretations of the same equation. Black hole is a physical body or a physical or a mathematical equation describing a physical object. Indeed, it's like this exists and black hole also exists. But wormholes are just theoretical passages from this universe to another universe or from this space to another space, but nobody has never seen these wormholes. But they could be used to make time traveling or to travel to another planet or another galaxies in a tiny amount of time. But they are